module 4, Cauchy integral formula for derivatives. Okay. So in this lecture we will discuss Cauchy integral formula for derivatives and KTU problems. KTU problem May 2019 and April 2018. Okay. So first we will discuss what is derivatives of Cauchy integral formula for derivatives. Okay. So this is Cauchy integral formula. Suppose f of z is analytic in a domain D, then it has derivatives of all orders in D, which are then also analytic function in D. That means if f of z is analytic, then we know that f dash of z, f double dash of z, every function, all its derivatives are also analytic. And these values of these derivatives at a point z naught in D are given by the formula. So if this f of z is analytic, then f nth derivative of z naught is equal to n factorial divided by 2 pi I integral over c f of z by z minus z naught n plus 1 raised to n plus 1 dz. So that is where c is any simple closed path in D that encloses um, z naught and whose full interior belongs to. So that means simply Cauchy integral formula is this. That means if f of z is analytic in C, I am taking domain as C, and z naught be a point, okay, and let capital C be any simple closed curve. That means if this is our C, and suppose this is our simple closed curve C, so f of z must be analytic inside C, and C be any simple closed curve. Let z naught be a point in C. So I am taking z naught is a point in C. So ഈ സർക്കിളിൻ്റെ ഉള്ളിൽ or this simple closed pathൻ്റെ അകത്തുള്ള ഒരു പോയിന്റ് ആണ് z naught. Then integral over C f of z divided by z minus z naught all power n plus 1. Here n plus 1 dz is equal to 2 pi I divided by n factorial f nth derivative of z naught. Okay, so this is the formula. So if f of z, the condition is if f of z is analytic inside CB, okay, analytic inside C. So if you have f of z which is analytic everywhere inside this closed curve C, simple closed curve C, and CB any simple closed curve, and z naught be a point in C, then integral over C f of z divided by z minus z naught all power n plus 1 dz is equal to 2 pi I divided by n factorial f nth derivative of z naught. Okay, this is the formula. So what we have to check? We have to check first we have to draw the given curve C, and we have to check whether f of z is analytic inside C, and we have to check whether z naught is a point inside C, and then we can use the formula. So I will do first problem. So we can do first problem. If you have any doubt, you can. Okay, the problem is using Cauchy integral formula for derivatives, evaluate integral over c e raised to z divided by z square plus 4 into z minus 1 all square dz, where c is a circle mod z minus 1 equal to 2. Now, solution. We have this function. Okay, e raised to z is always analytic, and z square plus 4 into z minus 1 all square. So in the denominator we have z square plus 4 into z minus 1 all square. This we can written as e raised to z. Z square plus 4 is z minus 2i into z plus 2i into z minus 1 all square. So this function is analytic everywhere except except എവിടെയാണ് അനലിറ്റിക് അല്ലാത്തത്? എക്സെപ്റ്റ് അറ്റ് z equal to 2i, z equal to minus 2i, z equal to 1. Except, so in that points, the denominator becomes 0. Except at z equal to 2i minus 2i and 2. Sorry, and 1. So it is analytic everywhere except these points. Now, what is our C? Then we will draw C. Curve C is mod z minus 1 equal to 2. So, first we will draw. So, mod z minus 1 equal to 2 is a circle with the center 1 and radius 2. So, this is 1. So, and again. So, this is our circle. So, this is center. Now we have to check whether these points are inside the circle or not. So if you take 1 is always inside the circle. Now we have to check whether 2i or minus 2i is inside the circle. So how to check? So our C is mod z minus 1 equal to 2. Now that means from a set of all points z such that z mod z minus 1 equal to 2. That's points. So now we will check. If I put z equal to 2i, then mod 2i, instead of z I'm putting 2i minus 1. So this is equal to minus 1 plus 2i, which is equal to, so the distance from 2i from 1 is this. So we know that this is equal to minus 1 square plus 2 square, which is equal to root 5. So root 5 is greater than 2. Therefore, this distance from distance of 2i from 1 is 1 is outside the circle. Okay, so 2i is outside the circle. And now you check what about minus 2i. Z equal to minus 2i. Similarly, instead of set I will put minus 2i minus 1 is equal to, you will get again this is root 5, which is greater than 2. So minus 2i is also outside the circle. So z equal to 2i and z equal to minus 2i is outside the circle. Thus e raised to z divided by z minus 2i into z plus 2i into z minus 1 all square is analytic everywhere where except at z equal to 1 inside C. So what is C? This is C. So this is analytic everywhere except Z equal to 1 inside C. Therefore, you can write this as e raised to Z divided by Z minus 2I into Z plus 2I is Z square plus 4. So I am taking it on the numerator divided by Z minus 1. Okay. So here f of Z, you can take it as numerator part e raised to Z divided by Z square plus 4. Now, therefore, now what is Cauchy integral formula for derivatives? So that is equal to Cauchy integral formula for derivative integral over C f of Z divided by Z minus Z naught all power n plus 1 dz is equal to 2 pi I divided by n factorial into f nth derivative at x. So this satisfies a very condition. So here z naught is equal to 1 and n equal to, what is n? So here n plus 1 is 2. N plus 1 is 2. N equal to 1. So n equal to 1. Therefore you can write integral over C e raised to z divided by z square plus 4 divided by z minus 1 all square dz is equal to 2 pi I divided by n 1 factorial into f dash of z naught is 1. Okay, so this is the answer. Now I have to find out what is f dash of z. So f of z is equal to e raised to z divided by z square plus 4. Now, what is f dash of z? F dash of z is derivative of this. So that is equal to z square plus 4 into derivative of e raised to z, that is e raised to z, minus e raised to z into derivative of this. So that is 2z divided by z square plus 4 all square, which implies, now I will put what is f dash of 1. So this is, instead of z I will put 1 plus 4 e minus e into 2 divided by 1 plus 1 square plus 4 whole square. So this is equal to, this is 5e minus 2e, that is 3e divided by 1 plus 4. 1 plus 4, 5. 5 square, 25e. Thus, we have integral over C e raised to z divided by z square plus 4 into z minus 1 all square is equal to, what you can write, is equal to, this is 5 divided by 20, sorry, 3e divided by 20. This is equal to 2 pi I divided by 1 factorial into f dash of 1 is 3e divided by 25. So this is the answer. Okay. So 2 pi I into 3e divided by 25. So this is very easy problem. So what we have to do is, just we have to check, first we want to find out what are the singular points, that points which are not analytic. So we'll find that, that means we have to check when the denominator is 0. So we find that these points. Then we draw the curve, simple closed path. This is a circle, and find that both 2 points are outside the circle. Therefore, it is not analytic only at z equal to 1. So then we can easily use Cauchy integral formula and we can find solution.